Welcome to today's deep dive, where we are looking at something called life harness. And our mission today is to unpack this critical bridge that stops AI agents from just completely failing at surprisingly simple tasks.
Yeah, simple tasks like, just trying to click a next page button on a website and totally freezing.
Exactly. And it really proves why just scaling up, like building bigger and bigger models, isn't the only way forward for you or anyone using these tools.
It really is a fascinating reality check. I mean, we assume an AI that can write a symphony should easily navigate a basic software API, right?
I think so, yeah.
But AIs are probabilistic, they're creative. APIs are completely rigid and unforgiving. So without the right interface, these models just stumble.
Right.
Life Harness acts as this necessary translator so the AI can perceive, act on, and actually get useful feedback from real environments.
So let's break down this problem first. Like, why does an AI struggle so much with basic tool use? If it doesn't know the specific formatting rules of, say, a new software environment, can't the developers just, I don't know, retrain it?
Well, they can, and honestly, that has been the standard approach. You just adjust the model's internal weights so it learns the new commands.
Okay, so that solves it, right?
Not exactly. Doing that often triggers what we call catastrophic forgetting.
Right.
Because in a neural network, the mathematical pathways for logic and reasoning are deeply entangled with the pathways for basic text generation.
Oh, wow. So they're all mixed together.
Exactly. You can't just isolate and tweak a code generation module without, damaging the rest of the web.
So it's almost like doing brain surgery on a genius mathematician just so they
Yeah.
can pass a standard driving test.
Yeah, that's a good way to put it.
Only to realize after the surgery, they completely forgot how to do calculus.
Precisely. You cure the immediate symptom, but you severely damage the core intelligence. The AI perfectly learns how to format a search query, but, it loses the reasoning ability to understand what it's actually searching for.
Yikes. So if performing brain surgery on the model destroys its logic, I mean, the only alternative is to control the environment around it, right?
Right. And that's exactly where Life Harness comes in.
Now, when I first saw this in the sources, I totally assumed it was a RAG system, retrieval augmented generation, where you just inject new knowledge into the prompt. But the researchers are incredibly firm that this is not RAG.
It is definitely not RAG. RAG is all about fetching facts. Life Harness is more of a short, punchy, no-fluff explainer of behavioral control.
Behavioral control.
Yeah, it sits directly on the boundary between the model and the environment. And the architecture itself is surprisingly simple. We're talking about lightweight Python code and regular expressions acting as a strict filter and corrector.
Wait, really?
Yeah, it's essentially an exoskeleton for the AI.
But wait, Python and regular expressions have been around for decades. How can something that basic act as a safety net for a cutting-edge, billion-parameter AI?
It does sound like a mismatch, right?
Yeah, massive mismatch in complexity.
I know, but it's incredibly effective because it acts as a mechanical nanny for the AI. It operates through very specific functional layers.
Okay, like what?
So the first is the environment contract layer. Think of it as a preventative safety net. Before the AI even attempts an action, this layer enforces hard-coded Python constraints.
Oh, okay, so it stops it from making a mistake in the first place.
Exactly. For example, it might block the AI from attempting broad recursive searches, just ensuring the system doesn't completely crash.
So it's basically putting up a do not enter sign before the AI can walk off a cliff.
Precisely. But what happens if the AI gets confused or gets stuck in a rut? That's where the trajectory regulation layer comes in. It's the loop breaker.
The loop breaker.
Okay.
How does that work?
Say the AI is looking for information and endlessly clicks next page on a website, but it's finding nothing. After the sixth click, this layer just physically blocks the action.
It just cuts it off.
Yeah. It forces a hard error back at the model, basically saying, look, you're stuck in a loop, change your strategy. It mechanically shatters that degeneration cycle.
Wow, so it acts as a literal physical circuit breaker. And then there's a third layer, right? The on-the-fly validator.
Yes, exactly. Before a command even reaches the environment, this validator catches basic errors. So if the AI forgets a JSON bracket or, makes a typo, this layer intercepts and fixes it.
Because missing a single bracket breaks the whole system.
Right. This stops the AI from failing just because of clumsy formatting.
So, I mean, the real takeaway from all this for you listening is that making AI useful for your business or your daily tasks doesn't actually require renting the heaviest LLM on the market.
Not at all.
You don't need to build city-sized data centers or burn millions retraining models just to fix basic errors.
Exactly. You just need to build the right exoskeleton around a lighter, more efficient model to protect it from the unforgiving structural rules of the real world.
Which leaves me with this final thought for you to ponder. If our modern cutting-edge AI constantly stumbles over archaic software code rules that were written by humans for humans back in the 2010s, what happens when we start building operating systems from scratch that natively speak the AI's language?
That's the real question.
Right. Will these exoskeletons just become completely obsolete overnight? Something to think about.